Hello, my dear students. Now we are having one question, and in this question, four long straight wire each carrying current 5 ampere are placed in plane as shown in figure. The point of intersection form a square of side 5 centimeter. First question is that find the magnetic field at the center of this square. Okay, so here we are having four long, very long straight wires. Okay, carrying current. Let us consider this current is I1. Okay, and this is current I2, this current is I3, and this current is I4. Okay, all value of this current I1, I2, I3 is equal, that is 5 ampere. So if we are finding the magnetic field at this point P due to this current I1, okay, first we are finding the magnetic field at P point. Okay, so the magnetic field at P point due to current I1, let us consider it is B1, which is equal to mu naught I, okay, divided by 2 pi. Okay, and we are considering the side of this square is A. So distance between this current I1 and this point P is A by 2. So we can write this A by 2. Okay, and the direction of this magnetic field using the right hand rule is into the plane of paper, so you can use this cross sign. Okay, same as it is, the magnetic field B2, that is the magnetic field due to I2, will again equal to this B1, that is mu naught I divided by 2 pi, and distance is A by 2 because it is the center. So this distance is A by 2, and I2 will also have distance A by 2 from this point P. Okay, so the magnitude of magnetic field will be equal, but direction is exactly opposite to the B1, which is outward to the plane. So you can use this dot sign to represent outward direction. Okay, and you can use right hand thumb rule to find the direction of B2. Same as it is, if we are finding B3, it is again equal to mu naught I, same magnitude is there, divided by 2 pi into A by 2. Okay, same as it is, we can find due to I3 also, and the direction is into the plane. Okay, again we can use you can use right hand thumb rule to find the direction due to this I3 at point P. Same as it is, if we are finding magnetic field B4 due to I4, it will be equal to mu naught I divided by 2 pi into A by 2, and this direction is outward to the plane. So if we are calculating the magnetic field at this point P, so all this magnetic field will aid, and definitely direction is opposite, so this B1 will cancel out by this B2, B3 will cancel out by this B4. So final, the net magnetic field at point P will be equal to 0. It is equal to 0. Okay, so the magnetic field at point P is equal to 0. Now if we are finding the magnetic field at this Q1, okay, the second part is asking for the same. Okay, what is the second part, B part of this question? Q1, Q2, Q3 and Q4 as shown in figure. This is point Q1, okay, this is point Q2, this is Q3 and this is Q4. Okay, are situated one of on the diagonals of a square and a distance from P that is equal to the length of diagonal. So if we are considering the side of this square is A, so this diagonal will have length A root 2. Okay, you know very well what is the length of diagonal of a square. It is A root 2. So from P to Q1, the distance is again A root 2. It is given A root 2. It is given in the question. Okay, but we require to find the direction. Sorry, we require to find the distance of this Q1 from this I1 current, that is the perpendicular distance. Okay, this blue color distance. So this angle is 45 degree, and this distance from this point of intersection, let us consider this point of intersection 1. So distance from 1 to q1 will be a root 2 by 2, that is equal to a root 2. And if we are using this component which is perpendicular distance from this I1 of q1, so it will be, this will be a by root 2. Okay, it is a by root 2, a by root 2 into cos 45 degree. Okay, this, if this distance is a by root 2, then, and this angle is 45 degrees, so if we are resolving and finding this perpendicular distance, it is a by root 2 into cos 45 degree. Okay, so it will become a by root 2 and cos 45, again a by 1 by root 2. Okay, so you will get a by 2. So this perpendicular distance between I1 and Q1 is a by 2. Okay, so if you are finding the magnetic field at this Q1, okay, magnetic field at Q1. Okay, so first we are finding magnetic field due to current I1, which is equal to mu naught I divided by 2 pi, and distance is a by 2. Okay, distance is a by 2. Now if you are finding the magnetic field, but what is the direction of this B1? Definitely, if this current is flowing vertically upward, so direction of magnetic field at Q1 is outward. Okay, so you can use the dot sign. But if you are finding the magnetic field due to current I2, let us consider it is B2. So it is mu naught I divided by 2 pi, and this distance will become 3a by 2. 3a by 2, because this distance is a and this will be a by 2. So total distance is 3a by 2. Okay, and the direction is again outward. Okay, and if you are finding the magnetic field B3 due to current this I3, okay, so it will be equal to B1 and the direction is outward. Okay, and if you are finding B4, it will be equal to B2 and direction is again outward. So all this magnetic field will aid. Okay, so the net magnetic field at Q1 is equal to 2 times of mu naught I divided by 2 pi into a by 2 plus 2 times of mu naught I divided by 2 pi into 3a by 2. Okay, if we are solving this equation further, this 2 will cancel out and this 2 again will cancel out. So this 2 mu naught I divided by pi a plus 2 mu naught I divided by 3 pi a. Okay, if you are taking LCM, you will get this 2 mu naught I divided by pi a as common, and in the bracket you will get 4 by 3. So final, the magnetic field at this Q1 is equal to 8 mu naught I divided by 3 pi a. Okay, now you can put value of this I and a and mu in this expression. So you will get magnetic field B at Q1 is equal to 8. What is value of mu naught? That is 4 pi into 10 raised to power minus 7. And current I is 5 ampere. And this 3 pi as it is, and the distance is 5 centimeter. A having value 5. So 5 into 10 raised to power minus 2. So this pi will cancel out, and it will become 32. Okay, 32 into 5 divided by 3. Okay, divided by 3 into 5 into 10 raised to power minus 10 raised to power minus 5. So this 5 again will cancel out and you will get 32 by 3 into 10 raised to power minus 5, and it will be in Tesla. Okay. Same as it is, if we are finding the magnetic field at Q3, you will get same magnetic field, because if you are finding the situation of Q3 will be very similar to Q1, but the direction of magnetic field will be into the plane of paper. Okay, so if it is outward, so the magnetic field at Q3 is equal to again 32 by 3 into 10 raised to power minus 5, but it is outward, so you can use, sorry, it is inward, so you can use the cross. Okay, now if you are finding the magnetic field at Q4 or Q2, so what you have to do, this magnetic field due to this current I1 and this current I2 will be into the plane, and same as it is, the magnetic field due to current I3 and I4 will be outward. Okay, so the magnetic field due to I1 will cancel out by magnetic field due to I3, and the magnetic field due to I1 will cancel out by the magnetic field due to I4. So the magnetic field at Q2 is equal to 0. Same as it is, magnetic field at Q4 again equal to 0, because it is very similar case to the Q2. Okay, because the direction of this I1 is into the plane of paper, and direction of this I4 the same amount of magnetic field but outward to the plane of paper. So it will cancel out, same as it is, I2 and I3 magnetic field also will cancel out, and you will get 0 at Q2 and Q4. But at Q1 and Q2, Q1 and Q3, the magnetic field due to all these four current will be outward. So you have to add all this magnetic field. Thank you very much.